Hello and welcome back. So over the past couple of videos, we have been doing nodal analysis on a given circuit. And the few videos ago, we were able to pretty much reduce, let me actually pull up the image file again. We were able to pretty much describe a circuit or come up with a 3-equation and 3-unknown system for solving our circuit, and we did that right here. So these were my 3 equations. I had 3 unknowns, I1, V0, and V3. And what we did in the last video was we talked about how we would use linear algebra to solve our circuit, and we were also able to put those equations, those 3 equations and 3 unknowns, into a linear algebra matrix expression, AX equals B. And we said that if we were able to invert that matrix A, if we were able to take this matrix A that we have and invert it and multiply it times our B vector, and our B vector is right here, if we were able to do that, then we would be able to get essentially our answers. We would be able to get all of our unknowns out of this problem. So what I'm going to do in this video is I'm going to solve that using a tool called MATLAB. So hopefully this isn't your first time seeing MATLAB before, but essentially MATLAB is a computer language. It's a high-level computer language. It's actually built on top of C++, and the graphics of it are built on top of Java. I'm using R 2011A right now. What you can do is you can actually use it. It's called MATLAB. MATLAB stands for Matrix Laboratory. And it's actually built to be like very much built on linear algebra and linear algebra concepts. So there are a lot of linear algebra types of operations built into the language, and the language makes it very easy to do linear algebra operations. And that's exactly what we need to do in this situation. So what I'm actually going to do, let's see if I can get rid of my workspace. I don't really need that. My current folder. MATLAB has got like this window right here. MATLAB kind of gives you tons of different windows for different things. Really all I need is my editor, because what I'm going to do is I'm going to write a script. And I also want my command window. My command window is kind of like my console output. And I can even in MATLAB, you can type commands just directly into the command window. So I can declare a variable, A is equal to 2. And then, let me actually get rid of the semicolon. The semicolon here suppresses print output. So I can say A equals 2, B equals 5. And then I can say A plus B. And it tells me that the answer is 7. So anyway, if I want to clear the screen, I type CLC. And then if I type clear, that clears all of the variables out of MATLAB. MATLAB has a workspace. It's actually a workspace that I actually just closed. But anyway, I'm going to clear all those variables. Now I'm going to do CLC to clear the screen. And what we're going to do is I'm actually going to shrink this, and let me get this picture that shows my AX equals B expression. So what we are going to do, I'm going to write a script to do this. So I'm going to clear the variables first thing in the script. Then I'm going to clear the screen. And then I'm going to input my matrix A. So my matrix A is going to be equal to these values. And the syntax for entering this in MATLAB is A equals square brackets, open square brackets, 1 space 1 over 6 space 1 over 4. And then I want to move on to the next row here. So I put a semicolon, and the other thing I should do in MATLAB after I put the semicolon, dot, 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 the ellipses means that I want to move this entry onto the next row. Or onto the next line of the program. So I put semicolon, dot, dot, dot. Then my next entry here is 0. So 0. Then my next entry is all of this. Notice I didn't simplify this, right, when I was going through all of that. Like I could, if I needed to write this answer down on an exam, I could have simplified this. But if I'm just putting this information into a calculator, I mean, if I simplified that, I'd make a mistake, right? I'd be just as, likely to make a mistake as I would be to get it correct. So I, want to leave that in this form and just let MATLAB do the work. Let MATLAB do the work of simplifying it. So I'm going to put that in as minus 1 over 6 minus 1 over 12 minus 1 over 15, close paren. And then the last part of this is 1 over 12, 1 over 12, semicolon, dot, 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 because I want to move on to the next row. Then the last row is 0, 1 over 12, and minus 1 over 4 minus 1 over 12, close paren, and then close square brackets to close this off. And now if I put a semicolon here, I'd suppress the print output, or I can just run this script right now. I'm typing on my Mac, it's command, hold down command and push enter will run this. On a PC, it's hold down control and push enter will run it. Wonder if hold down control and push enter runs it on a Mac. No, on a Mac you have to do hold down command, hold down the open apple, and then push enter, and that'll run the script. But I want to suppress the print output here. Next thing I have to do is I have to declare my B vector. So my B vector is right here. So let me go ahead and declare B equals open paren 3.3. I need 3.3 over 6 plus 3.3 over 4. Again, notice, I'm not simplifying those. Dot, dot, dot. Minus 3.3 over 6, semicolon, dot, dot, dot. And minus 3.3 over 4, minus 1, close paren, close square bracket, and suppress the print output with the semicolon. So now the last part is just if I was able to find A inverse, if I'm able to invert my matrix A and multiply it times my matrix B, that'll give me my X vector. So in MATLAB, there are a number of different ways I can do this. The correct way, or I shouldn't say it's the correct way, but the best way in MATLAB to do this is A backslash B. That's kind of the way MATLAB sort of wants you to do it. There's a lot built into that backslash command. I'm actually going to do, you can also do inverse of A times B. That'll work too. And then I think I'm going to do it like this. I'm going to say A raised to the minus 1 power, because that's what we kind of say when we want to invert something. A raised to the minus 1 power times matrix B. Those are all the different ways I can kind of put this in and get the output. And I also want to assign this to X. So X equals the inverse of A times my vector B. And let me run this. And I run this and I get my X output. So, I get my answers that my I1 is minus 0.7732 amp, V0 is 3.4014 volts, and V3 is 6.3254 volts. So let me just go ahead and I'm going to write that. Let me go ahead and I'm going to actually just grab a screenshot of this, and I'm going to put this back into my image file, and I'm going to go back over to where the circuit is. There, back to the circuit. And I'm going to paste. No, that's really small, but that's fine. So I paste my output in here. So I1 is equal to minus 0.7732 amp. V0 is equal to 3.4014 volts. And V3 is equal to 6.3254 0.254 volts. And now the last thing, we kind of wanted to know what I0 was, so let me just go ahead and calculate that. Because I0, we've already written what I0 was in terms of V3, V0, and if we just know V3 and V0, we take V3 minus V0, divide by 12. So if I do 6.3254 minus 3.4014 and divide that by 12 ohms, that'll give me I0. So let's go ahead and get the calculator. So calculator and 6.3255 minus 3.4014, divide that by 12, and I get 0.243675. 0.243 equals 0.24365 amps for I0. And what we wanted was V out. That was kind of the questions that we asked at the beginning of doing the circuit. We wanted V out, and we also wanted I0. So anyway, that's pretty much it. We used MATLAB to solve this. Hopefully, it's definitely a good skill to know how to use MATLAB to solve something like this. In the next few videos, I'm going to use different types of calculators to solve it, and different, maybe even we'll solve it by hand too. Hopefully your teacher doesn't make you do that because it's really pretty miserable. But anyway, yeah, we got our answer. So anyway, thanks so much for watching, and I will see you in a future video. See you soon. Bye.